In this lecture, we will learn about clustering and how to implement this type of machine learning algorithm in Python. Clustering groups data into clusters based on similar characteristics. For example, clustering could be used to create a targeted advertising campaign based on customer demographics. K-means clustering is an unsupervised machine learning algorithm. So this means that it tries to classify data without any training. It selects some random points in a cluster of points, averages their trend, and then determines new cluster centers by computing the average of the assigned points. Let's open up the terminal or command prompt program and cd into the directory where our Python file is stored. Then we need to install the pandas module. We will type pip install pandas. When we hit enter, the module will begin installing on our computer. Once it finishes, we are ready to open PyCharm and start writing some code. At the top of the code, we will have several import statements. We will import numpy as np and pandas as pd. Then we will type from matplotlib import pyplot as plt. From sklearn.datasets.samplesGenerator, we will import makeblobs. And from sklearn.cluster, we will import k-means. Next, we will create the variables x and y and set them equal to a call to makeblobs with nsamples equals 200 passed in as the first argument, centers equals 4 passed in as the second argument, cluster std equals 0.70 as the third argument, and random state equals 50 passed in as the fourth argument. Next, we will type plt.scatter and slice x starting at the beginning and ending at 0, and then slice x from the beginning up to 1. Then we will create a variable named wcss and set it equal to an empty list. Next will come a for loop for I in range 1, 10. Inside of the for loop, we will create a variable named k-means and set it equal to k-means with n clusters equals I passed in as the first argument, init equals k-means plus plus passed in as the second argument, maxiter equals 200 passed in as the third argument, ninit equals 10 passed in as the fourth argument, and random state equals 50 passed in as the fifth argument. Next, we will call k-means.fit and pass in x. After that, we will type wcss.append and pass in k-means.inertia. Outside of the for loop, we will plot the chart by calling plt.plot and passing in range 1, 10 as the first argument and wcss as the second argument. For the title, we will specify elbow method. Then we will label the x-axis number of clusters and the y-axis WCSS, which stands for within cluster sum of squares. Finally, we will show the plot by calling plt.show. When we run the code, notice that our blob clusters show, as does the line plot that maps them. The elbow method is called that name because if you notice the plot, it is in the shape of an elbow with a bend in it. In the next lecture, we will learn about recommender systems and how to implement this type of machine learning algorithm in Python.